So your book goes through kind of a convoluted way of showing that a function is increasing or decreasing. Um, what they say is, look, pick an interval, some interval around your x value. Okay, so for example, let's pick around our example, around 2. Let's go from 1 to 3. And what they say is, let's look at the left side of this. Well, on the left side of this interval, okay, so I'm not going to look at the endpoints, but I'm going to look at from 1 to 3, not including the endpoints. And so they say if our x value is stuck on this interval right here, okay, then f of x is clearly less than 4, because f of x, which is x squared, is always less than the n value, which is 2 squared. Okay, so that's true. Okay, now really they haven't shown for sure that that's actually always the case. Okay, so we would need to, you feel like there's got to be a little bit um, more to this than what the verification is. And then they say this. They say, well, if we look at the other interval, this guy right here, then we show that f of x, if x belongs in this interval, then f of x is always greater than 4, okay, which is equal to 2 squared. And so, since it's less than on one side and always greater than on the other side, it must be increasing on that interval. Okay, so that's not really it's not really a good way of going about it, but that's how they want you to work through the proof.